In Chapter 3, we start looking at solving equations, and this really gets to what many would consider the heart of algebra. So first of all, let's look at the idea of equivalent equations. These are equations that have the same solution or solutions. So for example, we could start with x plus 5 equals 10. This is equivalent to saying x equals 5. And of course, we generally would prefer that we would end up with this second form. That's what we're going to be trying to solve for. Now it's real important you understand the idea of inverse operations. We're going to be using these all year long. You'll be using them again in later math classes as well. So make sure you get this down. So the idea is that we have operations that undo each other. You have addition and subtraction. So for example, if you take 5 plus 3, you of course get 8. How do you get back to where you started? You start with 8. And instead of adding 3, do the inverse operation. Subtract 3, and you end up with where you started. 5, and you get back to 5. Multiplication and division. If we take, let's say, 4 times 3, this will give us 12. To get back to 4, we start with 12, and instead of multiplying by 3, divide by 3. And we end up with 4 again. Squaring and taking the square root. If we take, let's say, 8 and square it, this will give us 64. To go backwards, the opposite direction, take the square root of 64, the principal square root of 64, and we get 8. Okay, so we want to keep track of what those inverse operations are because we're going to be using those. We also have a number of properties that we want to look at. So addition property of equality says that we can add the same number to each side of an equation and produce an equivalent equation. So algebraically, if x minus a equals b, then x minus a plus a equals b plus a. In other words, add a to each side and we still have an equivalent equation. And the beauty of this now is this simplifies, because when we take x minus a plus a, we get x by itself, which is generally going to be our goal. And substituting some values here, x minus 3 equals 4. We can undo that operation by adding 3 to each side. So remember, you have to do that to each side, and we end up with x equals 7. The subtraction property is very similar, that we can subtract the same number from each side and get an equivalent equation. So if we have x plus a equals b, we can undo the addition by subtracting a from each side, and we end up with x equals b minus a. Or using numbers, x plus 3 equals 15. Undo that addition by subtracting 3. We have to do that to both sides, and we end up with x equals 12. Multiplication property says, guess what? We can multiply each side of an equation by the same non-zero number and end up with an equivalent equation. So we could have, for example, x over a equals b. We can multiply that by a. And we don't want a equal to 0 because remember, this is in the denominator and we cannot divide by 0. So with a not equal to 0, multiply each side by a. So here's a times x over a times b, and we get our solution of x equals a times b. Using numbers, we have x over 3 equals 12. Multiply each side by 3, the inverse operation. So instead of dividing by 3, take the inverse, multiply by 3. The 3's will cancel so that we get x by itself, and x is equal to 36. And finally, the division property of equality says that we can divide each side of an equation by the same non-zero number and produce an equivalent equation. So again, we do not want a equal to 0 because we're going to be dividing by a. So if we have ax equals b and we want x by itself, undo that multiplication by dividing by a on each side. So we get x equals b over a. So for example, 2x equals 10. Undo the multiplying by 2 by dividing by 2 on each side, and we get x equals 5. So let's look at some examples. Solve the equation and then check your solution. So we have x plus 6 equals 8. Inverse operation says subtract 6 from each side. So we get x. 6 minus 6 is 0, so we don't need to write it. 8 minus 6 is 2. Then to check our solution, we substitute 2 back in place of x and see if we get a true equation. 2 plus 6, and we want to know, does that equal 8? And sure enough, 2 plus 6 is 8. It equals 8 just like it's supposed to, so our solution checks. Okay, 7 equals y plus 10. Same idea here, it just happens that the variable's on the other side, but we want to undo that addition to get to the variable by itself. So subtract 10 from each side. On the left-hand side, we have 7 minus 10 is negative 3. And on the right-hand side, we now have y by itself. So to substitute and check here, we ask, does 7 equal negative 3 plus 10? And we have 7 on the left-hand side. Negative 3 plus 10 does equal 7, and so our solution checks. Okay, q minus 4 equals negative 9. So we're going to undo subtraction by adding. Add 4 to each side. On the left-hand side, we get q equals negative 4 plus 4 is 0, so that's gone. Negative 9 plus 4 is negative 5. And then to check our solution, we substitute negative 5 back in place of q. Negative 5 minus 4, and we want to know, does that equal negative 9? Negative 5 minus 4 is indeed negative 9, so our solution checks. And 3x equals negative 15. Here we're multiplying by 3. Undo that by the inverse operation, dividing by 3. So the 3's will cancel, and we get x by itself. And then negative 15 divided by 3 is negative 5. And to check our solution, we look at 3 times negative 5. And we want to know, is that side of the equation going to equal the right-hand side? And sure enough, 3 times negative 5 is negative 15. So negative 15 equals negative 15. We found the solution. Number 5, x over 4 is equal to 10. Remember, the fraction bar shows division. So we're going to undo the division by multiplying. So 4 times x over 4, we have to also multiply the right-hand side by 4. If you want, you can write this as 4 over 1. Either way, the 4's cancel. We're going to get x by itself, or x over 1, which is equivalent to x. So x equals 10 times 4, or 40. Then to check our result, we look at 40 over 4, and we want to know, does that equal 10? And sure enough, 40 divided by 4 is 10. 10 equals 10. We have a true equation. Okay, m plus 3 halves equals 8. So we're going to subtract 3 halves from each side. Now on the left-hand side, it's simple. We just have m by itself. If you want to subtract a fraction from a whole number, one thing that we can do is convert that to 16 over 2. So we want a common denominator. So we're going to look at 2. And then we have to multiply 2 times 8 to get 16 for our numerator. So 16 minus 2, or over 2, sorry, minus 3 over 2 is equal to 13 over 2. So substitute that back in place of m, and we want to notice 13 over 2 plus 3 over 2 equal 8. And we have a common denominator, which means we can add the numerators. So 13 plus 3 is 16 over 2. Does that equal 8? 16 divided by 2 does equal 8. So our solution checks. And finally, number 7, 2/3 x equals 18. You can look at this a couple ways. You could notice we're multiplying by 2, so we could divide by 2 in one step. And then we're dividing by 3. We could undo that by multiplying by 3 in a second step. Or you could be a little bit slick here and observe that we can multiply by the inverse of 2 over 3, which is 3 over 2. So this does the same thing. Instead of dividing by 3, we're multiplying by 3. Instead of multiplying by 2, we're dividing by 2. We're just doing both steps at the same time. So here we have to also multiply by 3 over 2. So the 3's cancel, the 2's cancel, so that we have just x by itself, or 1 times x, which is x. And then 18, if you want, you can write this 18 over 1 times 3 over 2. You can either multiply this out and get 54 over 2, or recognize that 2 and 18 give us an opportunity to do some canceling. 2 goes into 2 once, 2 goes into 18 9 times, so we end up with 9 times 3 is 27 over 1 times 1, which is 1, or in other words, 27. Then to check that, we look at 2/3 times 27, and we want to know, does that equal 18? If you want to write that again as a fraction over 1, we can do that. And then notice that 3 goes into 27. So 3 goes into 3 once, 3 goes into 27 9 times. We end up with 2 times 9 is 18 over 1 is still 18, and 18 does equal 18. So there you go. Pay close attention to your inverse operations. Please show your work and check your solutions, especially when the directions tell you to. Good luck.